Hey guys, today we're going to start with our very first video. Today we're going to go over our key concept 1, which is similarity and volume, target 1A vocabulary. So target 1A is similarity using transformation. So this video is just going to go over that vocabulary. Usually the vocabulary video wouldn't be assigned viewing. I know you can read through it. The vocabulary videos are always going to be there if you need an explanation of that vocabulary, but it won't ever be assigned. So this one was really just to get us started off, make sure we all can see the videos and we know what we're doing. So follow along, figure out some of this vocabulary. So the first thing we have is similar figures. Similar figures are figures that have the same shape, but not necessarily the same size. And the biggest thing we know about similar figures is that they have the same angles. Right? So they don't have the same size, but they have the same angles. Okay. So this butterfly, these two butterflies are similar figures. Right? Starting at this first one, right, to get to the second one, all it's done is it's gotten smaller and it's slightly rotated. But it's still the same exact shape. So this is what similar figures can be transformed, and that's what happened there, right? They can change where they are and how they look, but they're still the same shape. So transformations are operations that alter the form of a figure. The standard transformations are translations, flexions, dilations, and rotations. So this translation here, right? That's weird. The translation is really just moving that figure over. Whatever. The rotation rotates it around a point. So think like a carousel or a merry-go-round, right? If you move around that center point, you're still staying the same shape. You didn't change size. You're just moving. A dilation is getting bigger or smaller. I kind of like to think of it as you get closer to something, right, it gets bigger. The shape hasn't changed. It hasn't changed size. Or it hasn't changed shape. It has just changed size. Also think about how if you look at your eyes, right, a pupil dilates. So if you close your eyes for a long time and then open them all of a sudden, you'll see your pupil get bigger and smaller. It's not changing size. It's not changing shape. It's just changing size. And finally, a reflection. It's like looking at yourself in a mirror. You're still the same shape. It's just a little different, flipped, possibly. So all of these all are what we say preserve similarity. All four of these preserve similarity. So if I do a translation, a rotation, a dilation, or a reflection, my shape is still the same. Okay? So if that happens, we can say they're still similar figures. Our next vocab word is dilation, right? And so we're going a little bit more into that specific transformation. So a dilation is a transformation in which a figure grows larger or smaller in relation to a point or the center. So this right here is our center. Right? This here is our original figure. Right? And this figure actually got bigger. Right? This second shape is bigger. How do I know that's not the original and this figure didn't shrink? Well, you can see here in the naming that A prime is how you say that. It has a little apostrophe next to it. That means it's not the original. It's been named again after the original. It's kind of like a junior added to your name. So that tells me that that's the second figure and that it has grown larger. A larger figure, and I'll go over this too. Larger, right, is we call it an enlargement. So it's an enlargement, and smaller is what we call a reduction. So this was an enlargement, it got larger. Our next vocab word is a scale factor. Okay? It's the ratio of corresponding measurements of two similar figures. Now remember, these are similar figures, so if you look here, my angles are the same, just like we said, right? When we have similar figures, the angles are the same. What changes is the side lengths, right? Here I have a side length of 6, and here I have a side length of 12. So this one's much bigger. I want to know how much bigger, right? And that's where we take a ratio. Remember, a ratio is like a fraction. So I am taking EF, and taking this side here over this side, right? That's 2 to 1. That's if the second image was the second image, right? If I'm going from ABC to DEF. Right, so I'm starting at ABC and I want to know how much bigger DEF is. It's twice as big, right? 12 divided by 6, which reduces to 2 over 1, or just 2. The second one is DEF to ABC. Okay, so I started with this one and went to that one. Now I'm saying it's 6 over 12, which is 1 over 2. Right? So if I think this is my second one, it's gotten smaller than that first one. It's half the size. Just a few more things we're going to talk about. One of our main math words is called a postulate, and it's a statement accepted as true without proof. So a postulate is a statement accepted as true without proof. A postulate should be so simple and direct that it seems to be unquestionably true. One of the biggest postulates is what geometry is all based on, and that it is that between any 2 points you can create a line, a straight line, right? That just is unquestionably true. I can have 2 points and I can create a straight line between them. So one of our angle-angle similarity postulate is if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So if you can show that at least 2 angles are congruent, right? So A is congruent to D, and angle B is congruent to angle E, then I can say that these 2 triangles are similar. Not congruent, similar. They have the same shape, not necessarily the same size or in the same position. Right, and that's again going back to that first thing I said, where similar figures have the same angle. Okay. Our next one is side angle side similarity. Right, so if 2 sides of one triangle are proportional to 2 sides of the other triangle, and the angles between those sides are congruent, then the triangles are similar. And what I mean by that is, right, we have angle A and angle D similar. That's the angle between the 2 sides. Then I have AC in proportion with DF, right, and AB in proportion with DE, right? Those proportions are equal, and that angle between them is congruent. So these triangles are also similar. And finally, we have side-side-side similarity. So if all corresponding sides of 2 triangles are proportional, then the triangles are similar. And again, these sides are not congruent. They're in proportion. The ratios are equal. The sides aren't equal. So you can see AB over AB and QR, right? That ratio is equal to the ratio of AC and QS, which is equal to the ratio of BC over RS. So if all 3 sides are in proportion, then those triangles are similar as well. All right. Thanks, guys, for watching. I'll see you guys later.